For this video, I'm going to continue where we left off and discuss the fuel quantity display and control systems that would be found on a transport category aircraft. This goes in addition to the storage, fuel feed, refuel, defuel, and venting systems that were talked about in the previous lecture video. This is an example of a basic fuel quantity display and control. This would be on a little bit older aircraft, probably 757, 767 era. This is from an overhead panel. And you can see here we've got the top half of this is essentially a schematic of the fuel system. So you have in your left tank, you have an aft and a forward boost pump. In the right tank, there's an aft and a forward boost pump. And in the center tank, there's a left and a right boost pump. And those are all electric pumps. In the middle there, it's got item 2 and 10 pointing at it, is the crossfeed valve. And that would be opened in the case of needing to feed fuel to both engines from a single side. And so there is no ability, you can't move fuel typically from one side to the other on a transport aircraft, but if one side or the other becomes heavy, for instance, if our right tank were heavier than our left, you could shut off the forward and aft boost pumps on the left side, open that crossfeed valve, and both engines then would pull fuel from the right. There's a warning light in the middle for fuel configuration if something's abnormal. And then the lower third of this panel is the fuel quantity indication. And so it shows across the top, left, center, and right fuel quantities in thousands of pounds. So you have 40,000 pounds on the left and right, 14,500 in the middle shown here, as well as fuel temp. And then in the bottom right corner shows there's a fuel totalizer, total quantity. And so you can see here the wings are very heavy, the center tank is light, and that goes back to the fact that typically the center tank fuel would be burned from the center tank first to reduce that stress on the wing to fuselage joint. More modern aircraft, you'll see something that looks like this. And here we have an ICAST system, and on the left, again, you can see two tanks. Now in this case, the aircraft has the ability it has electric pumps as well as motive flow pumps. And so each wing tank has an electric pump shown here with a circle, and then a motive flow or venturi pump here that would get its motive flow fuel, the motive flow high pressure fuel from the engine. So as long as the engine is running, that pump would be moving fuel from those tanks into the manifold. And there is a crossfeed valve shown in the middle. That's the kind of this circle, and it shows it in the open position right now. You can see the APU draws fuel primarily off the right tank, but it can draw from either side. You have total on the left and the right, and now this airplane, the Embraer 175, doesn't actually have a center tank, but rather these extend into roughly the center line of the aircraft. The diagram on top on the multifunction display here shows the normal configuration. So there's a normal amount of fuel there. There's 3,500 pounds per side. If you look down below, it shows what the tanks would look like with additional fuel at 5,000 pounds per side, but with a low temperature. And then the center, it shows when the tanks get down here to 900 pounds, that indication turns yellow, and there's a yellow range on this little slider as well. And then on the right, when it gets down to 500 pounds, it turns red, and there's a red range on this analog type indicator here. And so with a ICAST system like this, it's able to provide those dynamic color changes and other alerts that older aircraft weren't able to. So this is the fuel system page on the multifunction display. On the primary ICAST display, it would show the fuel quantity just in numerical readings, normally below the main engine instruments. So we've got our main engine instruments, we've got the left tank quantity, right tank quantity, and then this is a totalizer in the middle. And below that, these two other items here, this one shows if there's an imbalance situation where the right tank is getting low, it's getting down below 1,300 pounds, and so that's turned yellow. And then if that right tank gets here, it's showing below 650 pounds, it turns red. And so again, that dynamic indication that color changes uh, with with different situations that the plane may be in, different configurations. These pumps on this aircraft are controlled with a panel that looks something like this. So you can see the AC pumps left and right at the bottom that were shown in the previous diagram. There's the crossfeed valve at the top, and then the DC pump for the APU. What's not shown here, the motive flow pumps, there's no way to control those other than the engine. So if the engines are running, those will be pumping. And I have a diagram here. This is a schematic of that aircraft now with the fuel system laid on top of it. Similar to the ICAST display, it's the same basic layout as the ICAST. But you can see here's our crossfeed valve, and that's the valve that it would open in the fuel system. And that allows us to feed both engines from either side in the case of a fuel imbalance. Here is our motor pump, AC motor pump control. Normally these are left in auto, and essentially they run when there's low fuel pressure in the manifold going to the engines. But if when the fuel pressure comes up, when the engine starts running and it starts operating that motive flow pump, that Venturi pump, that'll provide fuel pressure, and so these will cycle off. So that's what the auto mode is going to do. Here's the one for the right side. And then we also have a DC pump for the APU, and this is so that when the airplane's powered down, we can provide fuel pressure, fuel to the APU in order to get that started and then get the AC electrical system going that the main pumps run on and indication and all that kind of thing. So again, back to a kind of a cleared version of that. Here's another version, a little bit older. This is the CRJ series of aircraft. And again, here are just some things to point out. The fuel quantity indication. This is the main ICAST display. You can see there's a left, center, and in this case, the right tank, or sorry, the left, the right are reading 4,440 pounds each. The center tank is reading 0, and there's a total fuel, so that would be displayed to the crew all the time. The image on the right is the synoptic page, so this would be on the secondary display and would only come up when shown. But it shows the configuration on this aircraft where there is an electric pump on each side, a motive flow pump on each side. These are coming off the collector tank. There's actually another motive flow pump that helps move fuel into the collector tank, although it will gravity feed as well. And then those send fuel up to the engines. There is a crossflow valve that can open. It's this line here, and it does not connect to that center tube. That's why it kind of does the dip in the middle. The APU also has a DC pump, so there's a pump here, and this one's interesting that it draws from both left and right wing tanks and sends fuel up to the APU, and the APU is running. So that one actually draws from both tanks, but it's not tied into the engine feed system at all. It's got kind of its own independent. The control panel for this looks something like this. You have boost pump switches left and right. Again, the motive flow pumps are not able to be controlled by the crew other than, or the operator other than running the engines. And then some things for crossflow, the crossflow valves, which way to burn fuel from left to right or right to left. As well as this aircraft does have a gravity crossflow, which when you open essentially just connects the two tanks together. Last slide, there's a video you can watch on the A320 fuel system. I'm not going to put it in this video, but that link is in the slides on e-learning, and it's only about 5 minutes. I encourage you to take a look at that as well to learn a little bit more about aircraft fuel systems in yet another configuration.